Today we're going to see how we can sketch the root locus if we have a transfer function of this form. So let me give some numbers here. The k obviously is going to vary between 0 and infinity, and here we're going to put the coefficient. Let's just pick as an example 2 here, and then let's do 7 over here. So what we need to do is to specify to the computer a transfer function of this form. So we then will obtain the root locus plot, and then we are going to do other examples of the root locus plots. So let me disappear from here and concentrate on that. We're going to go to MATLAB over here, and then at this point we need to put the definition of what the numerator and the denominator is. So what I would suggest you do is define the variable s is a transfer function type of variable. Anywhere that you find s is of the transfer function type. That's what this statement does. Continuous time transfer function. So I'm going to say the numerator in here is 1, right? Is equal to 1. Yeah. The denominator, however, is equal to a product of s, as you saw in here, multiplied by the, what do we have? 2, right? We say 2s plus 1. Yeah. And then it was a product again. We said 7, right? 7 times s, and then plus 1. See, everybody agree? That's the denominator of this. And then we will put it like that. When we do that, the computer already has done the multiplications, and we have the denominator. So if we go to g and say g is equal to the numerator divided by the denominator, then we have a transfer function, you see. That is our transfer function here. Pretty simple, right? And if you follow my lead and do those definitions of the s variable as a transfer function variable, then it's very easy to manipulate the transfer functions in factor form. And to enter them in factor form. So if I say do the R locus, the root locus of g, guess what? The computer goes and thinks for a little bit, and is going to come out and give me the root locus plot without having to do anything by hand. Do you see in there? Now this is really nice. Let me help you recognize what we just have here. Isn't it true that in the denominator here, as you can see, is s to the cubic times 9s squared plus s. So that means you have 3 roots, right? That's what it means. One of those is 0 because of the way we define it. See, right? Perhaps a little, yeah, right here. See, s. So that is this blue one in here. The other one is at minus 0.02 or so, and you have another one at 0.5. Okay, so if you follow this, if k is equal to 0, they start over here. But MATLAB has done a very wonderful thing for us, because I want you to pay attention to this. See, this root, see, follows the blue path like that. See, this root goes like this. The other one, this green one, goes like this. Even if you sketch the root locus plot by hand, it's hard to follow which one goes where. But in MATLAB, you can actually do it. And in here, you see this one, the red follows the red path. So what you are seeing here is what you are seeing here is this the locus of all three of the roots. If in here, if you click on the plot, let's see where we are. The computer gives you the gain. It gives you where the pole is, what the damping is, and gives you the overshoot and the frequency. If you go to the intersection, this is where the gain is. See, you see that farther than this, you are not gonna get much response, other than if you go over here, forget it. With gain 15.4 as opposed to 0.8, the system just like it, you see overshoot 300%. That doesn't sound right, you know. But over here, look at the overshoot 0% in here. If you want to test it someplace in the middle, over here, see, then or over here, let's see, right there, 38% overshoot. So you can find out a lot of information by using the plot, and that's what these homework exercises would help you do. So in here, if we go back to the presentation that I started over here, we had this form. If we have this form, we know the root locus is going to be like this. See? We did it in a much more efficient way because in here we have MATLAB. This is one that is done by calculating angles and looking at the asymptotes, all that stuff, which I am not suggesting you do. Just use MATLAB. Okay, so that gives you an idea of what to do. Now we could go on and try this example in here and do some new root locus plot and try to understand a different transfer function in here. So let's give it a try to this one, okay? So I'm going to need the transfer function in this on its side. Hopefully well, let's close this one. We'll keep MATLAB open, and I just need this transfer function in such a way that I can read the directions. Okay, so if you do this one, let's see if we put it in here, and we are gonna do this transfer function here. So I would say in here I am going to type clear so that we clear all variables at workspace, and this is a suggestion from the textbook. We're going to define like say the numerator, we're going to call it P, is a polynomial that has 1 as a s, and then also plus 1. So you have it like that. Then we are going to define the denominator, which is q, and this is going to be with let's say 1 and 5 and 6 and 0, and then we close this over here, and then we'll define, we want the R locus of the transfer function between P and Q. You can do this directly, and then you see it's going to give us this, which is the explanation of what you see here. See, this is the you have the in a much nicer way with colors. This is the 0 and of course the other 3 roots. Okay, but let's examine what this other command does. See, this one, it says rloc find pq, which means follows the root locus function and find information for me. For example, we select a point on the graphics in here like that. I am going to reproduce this and do the same thing. So in here we're going to say r loc find of p comma q, yeah, and this, when you do this, you see how nice MATLAB is. It brings a cursor here, and just like it is on my left side over here, I am going to try to reproduce this and click close there. Watch what MATLAB does. See here, it gives you that's pretty close, you know. I got it. It says minus 0.05, I said 0.054, pretty close. And then, so when the crosshair placement, it gives you the conjugate pairs of the of that value, and it also gives you the gain. See here, this is the value of k on the selected point right here. So it is a very nice very nice tool. So you could actually do it in any other part of the plot. If you go back to the MATLAB, we have to have, of course, both of these open to be able to do it like this. You know, I will do. Please repeat the command. I'll say to MATLAB, and then it'll give me. And here I can go anywhere in here. Notice that the system is not going to become unstable at all. See, if we go over here, k is going to be really large compared to the other one, and the system has the roots still on the left hand side. So when you have this transfer function g, you could also look at the response. Like you could say, can you please give me the step response of the transfer function that is composed of this. Let me see if it does that. And it gives you the step response for this, or the impulse response. Let's see, you could do all kinds of things in here. Like, for example, you could say impulse response of P and Q, like that, and there you have your response. See? So by now you could see how powerful this technique is. we can know whether the system is stable or not. We can know how much control we can put before the system would give in. We can get the step response or the impulse response. We can calculate the overshoot and all the other values directly on the plot, because well, where is my root locus? We have to go back to here, to get back to the root locus. Where are we? Here, right here. Yeah. If you have this, with the cursor you could do it, but you could find it just if you click in on any point. The computer is going to give you all this information. See, damping, overshoot. So this is going to help you to, and I encourage you to explore all the tools available in MATLAB to extract information from the root locus plot, because it has all this wonderful information for you, like the gain, where the poles are, the damping, the overshoot, everything. So this is I'm going to stop now, because that was the purpose, of be able to demonstrate what the root locus plot can do for you.